Hello, our next presenter is Mike Young, who will be discussing asset management for utilities. Mike?
Thank you, Zach, and good morning, everybody. Certainly glad to see all of you here today. As Zach mentioned, we're going to be talking a bit about asset management. Obviously, this isn't a new term. Asset management has certainly been, it was probably the buzzword of maybe 6-7 years ago, but certainly still applicable to what we're doing here. Actually, if you Google it, you see the first definition kind of have up there at the top. I think this is more focused towards financial assets than assets underground, but I think it still really applies. O&M is really important, as well as upgrading your system. And the interesting one there is disposing of assets, which you don't really think about on the water side too much, but obviously how you deal with how the water itself can be an asset, and how that's disposed of or distributed, or however you want to view it, is certainly important as well as within your system. Many of you have requirements for asset management. It may come out as part of the private sector plans or long-term O&M plans by MWRD if you're in their tributary area, or it might be part of your CMOM program from the IPA. The second one here is kind of something that may be in your permit that you have with the IPA that you need to develop and implement an asset management strategy. Anyway, so we'll be talking about how this kind of applies for all your underground infrastructure, both sanitary, storm, and water. So this is kind of a list of the different elements of an asset management program. I'm going to touch upon each of these kind of briefly. I do want to bring up the fact that many of these we've talked about in detail. It had separate sessions on most of these, or even complete workshops on some of these over the past few years. So if those of you that are maybe here for the first time today, or have only come a couple of times and want to get into any of these issues in more detail that we're not covering today, on your evaluation form, just kind of note that if there's a specific thing you want to talk about, and say, hey, have Zach come pay me a visit, and let's talk a little bit more about flow monitoring or different types of condition assessment. Because I'm only going to touch upon these very briefly and kind of how it all fits together under a good asset management program. But you kind of see here what the elements are. Mapping in GIS, I'll kind of start everything with that one. Understanding your system and getting it all in GIS really is the first step of any kind of program. It's really the most important step. Obviously, operation maintenance that your staff does is really important within the system. I'm not going to talk a lot about that, but it's certainly a key part of what is of maintaining your system and maintaining your assets. Flow data collection, hydraulic modeling is certainly a key part of it, and I'll talk quite a bit more about that here in a minute, as well as condition assessment. But the key thing of all this is rehabilitation. If you actually study this but don't actually make improvements within your system, you only have it study on the shelf. So it's really important that everything that you do move towards actually fixing your system and extending the life of it, and giving, adding to your assets of what you've got. Obviously, once you get your plan, you move forward with design and construction, then it kind of repeats itself. Obviously, this is an ongoing process. So I want to talk a little bit more about each of those. Mapping in GIS, again, it really applies to all utilities. And certainly most of you have that process at least started. I think a lot of you, we worked with you on your sanitary system, so you got your GIS in pretty good order. Your storm system may be a little bit further behind. Most communities it is. You may not know what's going on. Maybe you've got some old maps that you can kind of pull in, but certainly actually locating things may not have happened. And same thing on the water side. Again, I think it's a little bit more common to have that in there, but the question is, have you updated? Have you gotten your valves located, for instance? And you kind of show here on this picture on the right, a situation where you're a couple hundred feet apart. You've got it generally that there's a valve on that line. But if you're that far apart, how is your staff going to be able to find it when you get that water main break? And they're looking for it at the one spot and it's pretty far away. They're not necessarily going to see it. So trying to get everything a little bit more accurately just for your operation and maintenance, much less all of your other work, is really important. Certainly want to bring up the fact that you want to make sure you're adding to your data all the time. So if you're getting new development that's coming in, or you have other projects that are being done, maybe in your road programs and so forth, making sure all of this information about your utilities and where your manholes and your valve outlets and so forth are located is getting into GIS as you go along. So keeping that updated as you move along in all of your projects. Flow monitoring is certainly a key part of what we do. I've done that with many of you, and it's certainly an early part of a program of really understanding what you've got. So it's really part of a proactive data collection. I'll talk a little bit more about how, proactive system of what that entails here in a little bit. The key thing is usually on focusing on wet weather flow reduction, of really understanding your system better, about your, the peaking factors that you've got, and just getting information about where to focus your condition assessment. If you do have capacity issues, you need to doing some hydraulic modeling with it. Hydraulic modeling is really critical to have both of these items in there. You've got to have the information about your system in there, the physical data, and also really good flow monitoring data to get a good model prepared. We'll also talk a little bit about overflow alarming and monitoring in some ways that can kind of play into your operation and maintenance. So I'll kind of end with my session here. With hydraulic modeling, again, it's usually focused more on capacity concerns that you have within your system. If you don't have capacity concerns, you don't have backups or overflows, things like that, you don't necessarily need to go in this direction. But if you do, it's really good to have a hydraulic model created. The good thing now is they're all GIS-based. If you have good GIS data, it needs to be survey grade if you're doing it for a model. But as long as there's good data in there about your system and good flow monitoring data, you can create a really good model. We've done a bunch of models in the last few years where we've made improvements then and actually reviewed it back after the fact and seen how closely what actually occurred matched up with the model after the improvements we made. And it's pretty amazing of how close it can be when you have really good data, how good the models are these days. So certainly, if you've got some challenging situations, certainly encourage you to do that. Obviously, you need to calibrate it to make sure you get the model set up well, both on dry weather and on wet weather. And then you look at your options and you look at different things and what you can do. And again, sometimes it's a combination of flow reduction as well as some capacity improvements or storage that you go into. And again, I've talked a bit about that in detail at some previous workshops we've had. On the water side, very similar. Obviously, you're pulling a little bit different data into it, but you're still putting some flow and pressure information that you're getting into the system. Again, GIS-based, making information about your system. And you certainly want to calibrate as well. I mean, it's a little bit different of how you calibrate it as opposed to a sewer model, but it's still good. It's still good to look at in terms of what kind of flows are you getting out there to make sure you're getting the fire flows and maintain the pressures you're looking for within your system. Because that's usually why you're setting up a hydraulic model on the water side. And again, you look at your options going forward of how to improve the system. And finally, for both of these, the ability to updates is really important. Again, you don't have to just create a model and leave it there. You can actually update as you make improvements or put the improvements into your system and see where you're really at. And that can really help you with your O&M procedures going forward. Condition assessment, again, we've had entire workshops based on a lot of the condition assessment. So again, if you want more detail on any of this stuff, we've got a lot of presentations we've done over the years. But just kind of reiterating the key parts of it. Obviously, smoke testing, manual inspections, TV inspection, dye testing are all things that we do on a regular basis out in the field for many of you already. On the private side, again, our private sources, is that really part of your assets? It is impacting your assets, so it's certainly still something that you should consider, and there's different options with that. And of course, we talked quite a bit this morning already about lift stations and force mains and how important it is to really know where you're at with those and that you're getting the useful life out of them and dealing with they need repairs and they need replacement. Condition assessment on storm sewers certainly isn't as common, but I think it's still important to do some of that as you go along. I think a lot of things with storm sewers you can really do with part of your other programs, really particularly with your road programs. I know for some of you, it may be all under one person that's doing all of this, but for some of you, the road program may be handled by a different group, where maybe engineering is handling the road program and public works is doing the sewer work. And so the question is, on part of the road program, are you talking with each other? Are you actually doing inspections? Are you updating your maps as you're doing your road program? Are you getting the improvements that you need as you go along? You're having to go back later. You're not getting improvements to your sewers as part of your road program. So certainly something to really think about going forward. Also want to think about cleaning. I think we've seen a lot of examples as we've done some projects recently. We'll talk about some this afternoon about the fact of how much cleaning certainly needs to be done at times, of how much debris can be built up in your storm sewers that can really impact that capacity. So doing some televised and trying to get that information, knowing where some sewers that need to be cleaned on a regular basis are, it's good O&M work for you going forward. As far as water condition assessment, Ian's going to talk a lot of detail about that in the next session, so I'm going to let him cover that and kind of move on to rehabilitation. So on the sewer side, certainly you do your point repairs. The last couple of years, we've talked a lot about sewer lining and about how to enhance that moving forward. So I just want to reiterate and also share for those of you that might be new this year. We really push hard when you're doing your sewer lining to add end seals, particularly if you're trying to reduce flow. What the end seals do, they seal up between the liner and the hose pipe at the end of it, because the liner kind of expands out to the hose pipe, but there's still interstitial flow that flows between them. And so you seal it at the end so that flow does not get into the manhole. Otherwise, you can just get that flow coming to the manhole anyways. You may be doing the structural improvements to your sewers, but not the flow reduction. So flow reduction is important to you. Certainly add the end seals in that. The same concept goes with lateral grouting. You can still get that flow to come out at the laterals because you got to cut, obviously, the lateral opening. You got to cut the liner. So it's important to grout that as well. And again, that's relatively, I mean, it adds cost to it, but considering what you're trying to accomplish there, it can certainly help quite a bit. And then finally, dead laterals. We're finding a lot of the projects we've been doing lately that we're seeing 15–20% is pretty typical for how many dead laterals are out there on a system that may be, you know, from the 50s and 60s and that kind of time frame. So certainly want to encourage that, because again, that's a lot of flow that if you don't have to reinstate that and get out of the system, it can significantly improve what you're trying to do. Manhole rehab, obviously is a key part of it. There's certainly lots of elements of that. I know I could get into a lot of detail on that. Catch basin inlet rehab is something we want to look at. And I just talked about the road program, making sure you're actually, if you got a road program, doing inspections with that road program and setting standards so that they're in your specs for your road program of how you're doing your chimney seals, how you're doing other things that you might be doing to improve your manholes, catch basins, and inlets. It's really important. And a great way to chip away at some of these issues without you having to handle them later, and certainly without having to dig up something that's brand new going forward. Finally, private sector, again, can be an important part of rehabilitation, something to consider. On the water side, Annie's also going to talk a little bit more about a rehabilitation and replacement with that. So what I want to move in with the rest of my presentation is talking about different approaches to maintaining your assets going forward. And obviously the most basic version of it is doing more of a reactive approach, where it's just kind of things happen and you fix them as you go along. So obviously you're taking that approach on the sanitary side. You may be doing your general O&M, but just kind of addressing overflows and basin backups as they occur, problems with pipes, whether it's surcharge or collapse, force main breaks, all of that. You're kind of just reacting. Something goes wrong, you fix what goes wrong. Obviously, a lot of you doing a lot more than that. A lot of that's why you're here today, is because you are doing a lot more than that. But certainly, that's kind of the basic approach. And we'll talk more about how, you know, take steps above and beyond as you go forward. On the storm side, you may be more reactive on that. It's not as common to do as much with the storm side, but there's certainly some things that you can do to go beyond reactive. But certainly on the reactive side, you're basically just addressing your flooding or problems with your pipes as you go along. Maybe your only work that you're doing if you're just doing a reactive approach. On the water side, again, are you just kind of waiting for water main breaks to happen, that you're just fixing them when they do happen? If you happen to find some valves while you're fixing a water main break that don't operate, and you try to get those valves fixed, maybe your fire department tells you about a hydrant. Again, I think for the vast majority of you, you're doing much more than that. You're doing hydrant flushing and other things as part of your system that are part of a proactive approach. But certainly, I want you to think about, are you only doing reactive, or are you doing more? So as we jump to proactive, obviously there's a lot more that you would do with that. Again, for each one of these, you're going to see the same thing. Good mapping in GIS is really the first step. That's for all of these systems. On the sanitary side, fog and root control, I think, is a really important part of any system, particularly if you've had any instances of dry weather overflows. Grease is usually the most common factor of why that happens. And so if you do have those issues, do you have a program in place to make sure that you're minimizing the risk that you have of that? And there are some other things that you can also look at going forward in terms of some monitoring that you can do to kind of help that process that I'll talk about at the end. Certainly flushing and cleaning. I think a lot of you have programs for that, maybe part of televising, maybe separate. You probably know a lot of where you have certain areas that need it on a regular basis. And again, we'll talk a little bit later on about how to improve that process. Certainly flow monitoring modeling, talked quite a bit about in the past. It can certainly be part of a proactive approach. And certainly annual condition assessment and rehabilitation, I think is important, particularly with the group that we have here. some may do it, you do it all at once and so forth, but most of you have the ability to have a certain amount of money in your budgets every year for doing some condition assessment and some rehabilitation. And that's really the best way to do it, is just to kind of keep it up over time and fitting it within your existing budgets. That way you can avoid many of our larger clients that we work for, have some kind of consent order, some kind of more regulatory enforcement. And if you can keep up with it and avoid getting into that, that's the much better approach to have. And obviously, in some cases, you may need to do even a little bit more than that if you have some capacity issues. Certainly on the storm side, I think there's lots you can do on the proactive side. Certainly cleaning, many of you do clean your catch basins out. Maybe do some sewer flushing to remove your any debris that's kind of built up in that to kind of maintain your capacity. A lot of you have MS4 programs that may involve, evaluating things with your outfalls, maybe even doing some sampling within that. And so those are certainly important to do. And I think that's a great way on the O&M side to really be proactive and try to minimize the risks you've got. Certainly going a little bit above and beyond that. You get into televised and manhole inspection. There are some communities that are starting to do that. If you feel you're pretty well on top of your sanitary system, want to get a little deeper in the storm, certainly encourage you to do that. Potentially even getting into some modeling, particularly if you have some flooding concerns that are out there. And doing some of the same improvements that you might do on the sanitary side as you need to be in terms of rehabilitation. Again, it really depends on where your system is. Again, if you're really focusing on your sanitary system first and then your storm system, that can be fine. You just want to focus on those maintenance type activities, but certainly something to consider as you go along of trying to be more proactive on the storm side. Finally, on the water side, I'm actually splitting this up in kind of 3 different groups. I think the first one is more focused on the maintenance activities that you might be doing. Many of you are doing hydrant flushing. I know that's usually at least once a year you're doing that, which is really important and good to making sure you both clean your system out a little bit and test your hydrants. Certainly valve exercising, some of you are, some of you might not be. You might be doing that to go along, or if you've got a formal program, that's certainly something you want to consider if you're not doing that. Because certainly you don't want to, when it's critical, to not have those valves working. And final pressure testing monitoring is certainly important as well. And the next group is more of what Andy's going to talk about here in a minute, which is more condition assessment on the water side. So certainly if you want to go a little bit further with your proactive approach, that can certainly be good with leak detection, and other types of condition assessment. And again, potentially get into modeling. If you've got some pressure issues, you're not meeting your required fire flows, that may be very important to know exactly what you need to fix within your system, which is kind of the third grouping I have. For the most part, when you're doing rehabilitation or more frequently even replacement on your water mains, you're usually using one of these things, age material, potentially size. If you got some 4-inch that you're trying to upsize, for instance, it might be there. Oftentimes break history can be a key leading factor of what you want to focus on. But certainly if you're doing some modeling, you find some pressure issues within your system, that can be a reason as well to move forward with some replacement. So next, I want to move on to predictive approach. That's kind of taking the proactive approach a little bit further to additional steps. But it's important when you look at predictive approach, you need to have all of the elements within that. So even though it's not making it predictive, the first step again is that physical data. You've got to have that. You can't move into any of these things without having good physical information about each of your systems. Next, I have 2A and 2B. 2A being flow data, whether it's flow monitoring or data on the water side that you're collecting and modeling, or condition assessment. Again, these can move together. You can do them both, or you may have a system that you're doing one or the other. If you don't have significant capacity issues, you may not worrying about. You may just move right into condition assessment and doing your plan completely based on that. If you have more of a capacity issue, that may be your primary focus, may be off your model that you're doing your improvements on, and you're not worried as much. Particularly on the water side, you may be, okay, my model says I need to work on this. You're not doing as much a condition assessment. So we can go either way. That's why I said they're both step 2, and there's different approaches you can take depending on your system. So that's certainly all part of the proactive approach that we've just been talking about. So to take it a little bit further, the next 3 steps are kind of really important. First, you have risk assessment. You need to develop your plan and then you implement your plan. And I'll talk a little bit more now about each of these 3 steps and kind of different approaches you can take to them. So for risk assessment, There's really two parts of it, which are basic and dynamic, and I'll discuss that in a little bit of what each of those are. But the primary elements that you're looking at with risk assessment are likelihood of failure and consequence of failure. Now, your likelihood of failure really comes from your condition assessment, the information you're gathering about your system. So it comes from, your likelihood of failure. Your 4s and 5s are going to have higher likelihood of failure than your 1s, 2s, and 3s on your PACP coding, on your sewers, your MAC coding on your manholes. So each of those things, that data you're collecting out in the field is going to really tell you the likelihood of failure to really plug that in. Then consequence of failure is what is the impact if that failure occurs within the system. And I'll talk quite a bit more about that in a minute, because that's a little bit different than what we've talked about in the past. And certainly as you put those two together, you can then become a ranking as you compare that, and you focus on the higher ranking for both of them first. You kind of work your way down in terms of where your improvements need to go. And we'll talk about how you can do that, again, in a basic way or a more dynamic way as you go forward. So as you're looking at consequence of failure, there's really three primary elements to that. The first one's economic. Obviously, the cost for the repair itself is certainly a consequence of it. It's certainly loss of revenue. Obviously, you probably consider that more on the water side. If you're losing some water, that's certainly a revenue source that you're losing. But certainly on the sewer side, that can be an issue as well. The key driver enforcement, a lot of this is social. That can certainly have a big impact. Obviously, it's the thing that can certainly get phone calls and Twitter feeds and other things that may be happening that can react to certain things that have come. So if you got to base some backups or loss of service, that can be really important. And a big part of it is location of the failure. And I'll talk a bit about that more on the next slide. Finally, environmental. I think that's becoming a bigger and bigger issue as we go along, certainly with the overflows that you may have, but even on the water side where it's impacting different things, that can have a pretty significant impact environmentally. And we're seeing a lot more activity, as far as, aquatic life and recreation. I know as we're looking on whether it's the Chicago River or the Des Plaines River and so forth, there's more people that want to be out in canoes or kayaking or, more fish that's coming in. So I think more and more that's going to become a bigger issue as we go forward on the environmental side. So you're taking more of a basic approach to consequence of failure. Obviously, the key part of that is that, we talked about that social impact of the location of the failure. And so getting a little bit deeper into that, I'm thinking about your critical infrastructure and critical locations. Obviously, your critical infrastructure is really what's transmitting most of the water, whether it's clean or dirty. Your transmission mains, your interceptors, your force mains, a lot of those are really, you don't really have another option beyond that. It can have an impact on a lot of people if something goes wrong with that. So are you doing inspections on those as you go forward? We certainly had some clients, you kind of see this is one of my favorite pictures. Many of you have been here, have seen it before, of the mushrooms growing on within an interceptor. And I know a few of you have internal staff that can clean and televise your smaller sewers, but maybe the deep interceptors you can't do. And you need to hire out to do that. Well, I think at least on a semi-regular basis, you need to actually do that, or at least inspect it to see if it needs to be done, because it's important to maintain those systems. And certainly critical locations. So critical cross inches you got of specific roads and railroads and rivers. But also a lot in terms of where things are located. Certainly downtown areas, and we'll talk a little bit this afternoon about downtown Glen Ellen and the work that was done there. To really understand what's going on, where there's some really old systems that have been there a long time that you may not know where things are at. And then difficult access. You've got, backyards or under buildings and so forth. There are things that are really important that you want to make sure you fix or you line so that you don't have to try to fix it later when it's going to be almost impossible. So certainly those are impacts or consequence of failure. And certainly other things can be certainly critical locations like hospitals or other schools, other things that could also rank high on that as you go forward. So with your basic approach, what you do with that is you pretty much, you kind of intuitively know where those things are. You kind of develop your plan based upon that, based upon your maps and so forth. And a dynamic approach would be more using computer programs. We typically use Infomaster for clients that want to do this. When you actually take that information and plug it into a program, get your likelihood of failure, consequence of failure, you have a decision tree that's going to help you kind of decide how you're going to prioritize, and you plug that all in, and it gets you a detailed asset plan coming out of it. So certainly you want to consider that going forward. I think a lot depends on your system. If you're something that you can do, you're going to be able to quickly fix your system and focusing on all of it, or you know what you want to focus on. This may not necessarily be useful for you, but if you got really a long-term program or you've got a lot of data that you want to help prioritize, these systems can be really good. Infomess can be a really good source of a program that can be useful to helping you develop that. Just a little bit more on that. Obviously, it really helps with the strategy of what you're doing, and it can really tell you a bunch of different things. It can tell you what needs to be fixed right away, and when it prioritized, it can tell you some things that maybe need to be inspected or maintained more frequently, particularly if they're not being fixed right away. Maybe they're more in the 5 to 10 year plan. And again, when all of this needs to be done, so you can set up for a 5-year plan, a 20-year plan, however you want to set that up, and whatever data you want to put in. It's very flexible of what it works with, and it works with all these different utilities as well. You can do it on the sanitary, on the storm side, on the water side. It has the ability to plug all of that information in and develop a really good plan. So certainly, again, if you got a lot of data and you're having a hard time knowing how to prioritize, this can be very useful for you. Okay, so far, if you really think about it, it's really still been more proactive. It may be getting a little deeper into proactive, what I've talked about with steps 3, 4, and 5, but it's still more proactive than predictive. How do we make it predictive? And the key thing for that is permanent data collection. You're going to be predictive, you got to be collecting data, real-time data, that you can plug in and tell you when a problem is going to occur, that you can deal with it before it actually happens, and that's what makes it predictive. So if we're looking at permanent data collection, so what data are we collecting? Obviously, we're talking about our water systems or our sewer systems. So we're collecting pressure data, flow data, level data. That's basically what we're trying to get within the system. And we're looking at real-time data. And there's kind of 2 ways that you can do that. You can do live data. And your live data is generally going to have AC power directly connected. And you could do that on the flow monitoring side. You can see we have this ISCO signature series down here and this HOC FL1500 that are both systems we use with permanent meters with AC power. They've got within a few systems. So sometimes those can be at lift stations where you have a power source right away that we use them, but certainly there can be other locations where you can get power to and want to really get that permanent information. On interceptors, we put them into. So certainly something you may want to consider going forward if you really want live data. But if you're putting in kind of your standard typical flow meter, AV flow meter that's just on batteries, you can have alarm set points. You don't want to put live data because your batteries are based upon how you transmit data. If you're transmitting data all the time, you're going to run through batteries, nothing flat. That's just not going to work. That's why you need the AC power. But if you have alarm set points, you can just, when those alarms are reached, then it sends that data. You can do that and still maintain things on batteries. So those are all really options that are out there in terms of getting that permanent data collection. And you can use that to update your models in terms of how you're planning. I think most importantly, update your operation and maintenance procedures. And I'll talk a bit about more of that at the end. Before we get to that, I do want to talk a little bit more about flow monitoring versus level monitoring. There's a lot of new level monitoring only equipment that's out there. This ADS Echo is one of them. They certainly are less expensive. You'll hear a lot of them of saying, hey, do this, just put them in. It's much easier. They're really easy to maintain and so forth, which is true. All that information is true, but there's still limitations on what you can get out of level monitoring. So where does each of them kind of come into play from our perspective? I think the key thing is if you're starting on a program and you're just looking to get some information how to prioritize what work you're going to do, or particularly if you're going to do a hydraulic model for your system, it's best to do the full flow monitoring. There's so much more information you get about how much flow you're getting, is there downstream control, do you have reverse flow where the flow's going the other way. Level monitoring is not going to get you that information. We've certainly seen things like that reverse flow happen, so I think it's really important, particularly if you have problem areas, that you get that full picture, get all that information in there. Where level monitoring works really well is in a couple different areas. One of them is, and we've used both in systems. So for instance, if we're doing an area that we're doing some regular flow monitoring and there's some overflows into those areas, whether it's from basin to basin or where we've used in one case, there was a combined system that could overflow in a separate system. We used the level monitor to know when that overflow occurred and then hit the flow meters downstream, but that way we could kind of use that information that we did have an overflow to kind of judge, okay, what happened at that point in time with the flow monitoring downstream. I think the biggest thing that level monitoring can do is get you that alarm information that can really help with your operation and maintenance going forward, and I'll talk about that here in a minute. Again, you got to think more about the power supply. Again, do you have options to do AC power in there to get live data, or you're going to have alarming set up? Again, alarming can be on all these, both the flow monitoring and the level monitoring have alarming capabilities now. All the modern equipment does. So again, if we're going to this predictive approach, you got everything set up with your proactive approach first, and then you're starting to add the permanent data collection. Then you can update that risk assessment, the models and so forth that you did in steps 3 and 4, and do the predictive monitoring that allows you finally to do predictive operation and maintenance. And I think that's the best use of taking this predictive approach. And so there's two different ways of viewing that. I'm actually going to start with maintenance first in this case, and I think maintenance is again with your own crew that you can do. So if you have something within your water system, you have additional locations where you're monitoring your pressure, particularly your problem areas, and you're seeing some issues, you can say, okay, this is where there's a problem here that's occurring, or maybe you need to use sign that there's potentially a break, particularly if it's significant, that you might be able to find from that. On the sewer side, I think the key thing is where you have your problem areas that are occurring and how you monitor that. A few examples for that. One is, let's say you have a siphon that you got in your system. Obviously, those of you that have siphons know that they have a tendency to plug. They're a maintenance concern. That's why you try to avoid them when you can. But certainly, they can be a major maintenance headache. So how often do you clean them? Well, you may have them in a cycle every 6 months or something like that. You have to be done. What you can do is actually put one of these level monitors upstream of your siphon, put an alarm on it that reaches a certain point, and the alarm goes off and says it needs to be cleaned. So that way your crews don't just go out there when they need, just because it's time to. They only go out there when they need to, when they're actually, before a problem actually occurs, you go out there. So that's how the predictive comes into play. Same thing if you have chronic areas that say grease buildup, or we're having some problem areas of dry weather SSOs. This can be a good way of monitoring that too, that you need to actually clean the sewers or do some other things with it. So again, using this predictive this predictive data to help you do maintenance to prevent these SSOs from happening. And then on the operations side, it's somewhat similar to that, but what's different here is it's more of making split time decisions to do improvements to make changes within your system operations to again prevent things from happening. On the water side, it could be increasing water pumping or some other things. If you're, hey, we got some problems here in terms of low flows, maybe there's some changes you got to do, or some other things that are occurring someplace else. You say, hey, don't use water here because we've got a problem that's occurring, or whatever the case may be. Certainly on the sewer side, and that's where we're really seeing it most, is really the flow diversion. And it really has to do with if you have active SSOs or CSOs that you need to reduce the amount of operation of those. And what people are doing is putting putting these systems into place to allow them to adjust where the flow is going, to reduce the overflow. So allow them to say, hey, we're going to divert some flow to an interceptor that has more capacity, or we're going to divert flow to a storage basin that could do it, or we're going to use our equalization basin out the plant a different way, or something that may be going on that allows you to reduce those overflows and allow you to keep within the regulatory requirements that you've got. So that's where we're really seeing things come into place for that, of really controlling and operating those systems and getting that live information or those alarm information on storm events that can know when things need to be done. So certainly encourage you, again, you can use that on a full level, you're getting full operation of your system, or just a couple key problem locations that you want to monitor. Certainly something to consider. It can certainly be very cost effective if you can compare to some regulatory activities or some other things that may occur because these problems have continued to be there without you knowing, and taking steps to prevent them from happening going forward. So finally, to summarize, again, I always talk about starting with mapping. That's really the first thing that you really want to do going forward, is making sure you have your maps. So before you worry about any of these other stuff, get your maps into place. And then take a proactive approach. At least start with that, making sure with all of your systems that you're really doing things to improve your system over time. Take that into a multi-year plan, and make sure that includes rehabilitation. Have a plan to continue improving your system over time. Again, you can really set up something that fits within your budgets, but making sure that it's amazing if you keep doing stuff every year after 10 years of how much you can get done within that time. And then consider the predictive monitoring I was just talking about, particularly if you've got some problem locations you really want to focus on. That's certainly something to consider. And with that, I'll see if there are any questions.